And starting off with this definition of electric potential difference, this is your volt. Now, in looking at your definition doc, you can actually just take that straight off. So just if you go to your definition doc, you just see that. But basically, it is defined by this formula over here, that V is equal to W over Q. You can write the Q as a small q or a large Q, a capital letters Q, either way. But it's the energy per unit charge. So it's looking at the amount of energy per unit charge between two different places. So if I have got, for instance, a positive charge here, and I have to move it from one place to another, I either gain electric potential energy or I change it into some other forms of energy. So if I got my positive charge here, and maybe it's between two parallel plates over here, like this, where one is negative and one is positive, they are connected to a source of electrical potential difference, a cell over here. Now, if I hold this charge over here, so I've got this charge, I'm holding it over there, if I let it go, what will happen? It will head towards there. It will change from, it's got, at this point over here, at point A, it's got electrical potential energy. Alright? As soon as I let go, it will move away because the positive repels the positive. It will move in that direction over there. It will gain what sort of energy? It will gain kinetic energy, and that will be according to the first formula in your data booklet, that EV is equal to a half mv squared. Alright? Now this EV is coming from this formula over here, because W here, W is equal to V times Q. VQ. So if we have got just one positive charge here, alright, that's the charge of an electron. Alright, charge of an electron, but positive, then this VQ is V times E, and that gets transferred into kinetic energy. Are you okay with this formula and that formula? Because this W over here is energy, and that's equal to your potential difference, your voltage, times your charge. No, the big W is your work or your energy. This W here is your energy in whatever form it is. Alright? It can be in the form of kinetic energy, it can be in the form of electrical energy, it can be in the form of potential energy. In this case, it's in the form of electrical potential energy.
What is
the E is a charge on an electron. This E here, yeah, this is the charge on an electron. We're talking about a positive charge here. So the proton, which is a positive charge, has got the same charge, but it's positive. Alright, but both of them are 1.6 times 10 to the negative 19 coulombs.
So if you talk about charge, you only talk about the electric charge?
Yes, yes. Alright, so when we have a charge moving between 2 points, it gains potential energy when it moves from there. If it's moving from one point to the other, where it gains electrical potential energy. In this case over here, for instance, say if I had an electron here, say if I had an electron at this point over here, and I moved it from there to there, alright? If I moved my electron from there to there, I would have to do work on that electron. I would have to force it over. So if I grab that electron and pulled it over to this side over here, I would have to do work on it. I would give it electrical potential energy. Now the amount of energy that I would give to it would equal, the W is equal to V times Q. In this case, if I say I had my V here, let's say it's 10 volts there. And that would be 10 times the charge on the electron, which is E. Alright, that E stands for 1.6 times 10 to the negative 19. And that would give me my energy in joules. All right? Does that make sense? Is that reasonably? Yep. Yes.
So what is the difference between
W and what is V is your energy per unit charge. This is your volt. All right, your potential difference. This is the energy per charge. Now we use that if I'm talking about a 10 volt cell. Basically, what it means that per coulomb, your charge gains 10 joules of energy. All right, so it's an energy per charge is your V, and your W is energy. So this is measured. This over here is this W is measured in joules. All right. And this over here is measured in volts.
But it's like the V is a subset of W.
Yes, we get our V by dividing our joules by our charge.
Okay, so before they move, it's potential.
That's right. So if I go from here to here, if I take this electron over here, and I take it from, let's say, from A to B, as I take it across there in this direction, I give it electric potential energy. All right, I give it an amount of energy, and that amount of energy, if this was 10 volts there, I would give it 10 E, or 10 times 1.6 times 10 to the negative 19 joules of energy, or 10 eV. We will look at that a little bit more detail when we define the electron volt. I'll spend a little bit more time on that. So I will give that, as I go from A to B, I'm actually going to give this electron this amount of energy, but it's in potential energy. It's electrical potential energy. As soon as I let it go, so if you say you got your electron here, I let it go, it would shoot back in that direction over there. It would change its electrical potential energy into your kinetic energy. According to our formula, EV is equal to a half mv squared. Our half mv squared is our formula for kinetic energy, EK. And that would equal to that. That would be your energy altogether. And it so changes into kinetic energy. So it gains velocity. So it's just the same as in with dealing with mass. All right. So when I lift something up, all right, I give it potential energy. I drop it. It gains kinetic energy. It changes from this is potential energy due to its mass, and it drops. It gets kinetic energy. Now charge is stuff. It's like mass, but it's charge. It also gains now potential energy, but we call it electrical potential energy because it's dealing with the charge, and that can be changed into your kinetic energy.
So it charges. You said it's like stuff. So I mean, like a bunch of electrons.
Yes, each electron has got a certain amount of this stuff called charge. All right. And we define, and when we measured it in terms of coulombs, we defined it. It's 1.6 times 10 to the minus 19 coulombs of this stuff called charge. And with charge, you get a negative and a positive, and on a proton, you get the same amount of the stuff, charge, as with the electron, but it's positive.
So if moving from the electron from positive side to negative, we're giving it the potential energy.
Well, yes, by moving from the positive to the negative, the electron, we are gaining in electrical potential energy.
We're getting electrical potential.
Yeah.
We're releasing, we're getting
Kinetic energy. Yeah. So you get the same. It's both energy. So they're both measured in joules. All right, now, just to define this idea of an electron volt, because these energies are so low, like for instance, if I take the situation where I had my potential difference was 10 volts and I'm dealing with an electron, so the charge on an electron is 1.6 times 10 to the negative 19 coulombs. Sorry? It's always a constant, yes. That's a set amount. And any charge is always a multiple of that. That's the smallest amount of charge you can have. It's like a building block of charge. Now, when I work out my energy, my W, V times Q, I get 10 times 1.6 times 10 to the negative 19 joules. That's 1.6 times 10 to the negative 18 joules. That's very small. I mean, 10 to the minus 18. Okay, it's a millionth of a millionth of a millionth of a joule. A billionth, a million billionths of a joule. I mean, to raise something that has a mass of 1 kilogram, say if this battery here has got a mass of 1 kilogram, 1 meter, I'm using 1 joule. A joule isn't all that much. Alright? So if I'm talking about that, this is really small. So they said, okay, we need another unit to describe this. So they talk about an EV, an electron volt. An EV, this is an electron volt. Basically what it is, I wouldn't write this as 1.6 times 10 to the minus 18 joules. I would write this as 10 EV, where this E is 1.6 times 10 to the negative 19 coulombs. Alright? So 1 EV is equal to 1.6 times 10 to the negative 19 joules. That's your conversion between the two. And it's the energy that an electron will gain when you move it in a potential difference of 1 volt. Alright, that's the energy that an electron will gain when it moves from one point to another point, where the difference in potential energy, electric potential energy, is 1 volt. Does that make sense? Yes.
Just one like technical thing. Is it true that like the electron, that the charge of the electron is the same as the charge of the proton, except that the sign is changed?
That's exactly right, yeah.
But shouldn't it be a bit different because the protons and electrons have different mass? Yeah,
Have got different?
they've got different mass.
Okay, it's not mass and charge are two separate entities.
Yeah,
There's no connection between
No, no. It's spread out. That charge will be spread out over a larger surface. So the charge on an electron is more concentrated than a charge on a proton. Okay, it's more concentrated, but it's the same charge. Yep.
where do we get the
10 to the 10 EV, because I had I said that my voltage was 10 volts, and I have my charge was the charge of an electron, which is an E. So it's 10 volts times the charge of an electron, that E.